presentation shows the mineral admixtures, their types like Flyash, DGBFS, Metakaolin, Micro-Silica, etc. The mineral admixtures and Portland cement, all of them have some specific properties. For most of them are their particle size distribution, chemical and physical properties, rate of their chemical interaction with water and other materials present nearby. Net result of these interrelated and interactive intrinsic properties is that the development of strength and the microstructure of concrete is a time-dependent property influenced by nature of initial curing and about the properties of these materials, etc. While initial strength development has its own advantages like removal of formwork and the speed of construction, etc., but the durable service life of the structures mainly depend upon its impermeability, that is, how much is the rate of ingress of moisture and other ionic substances into the concrete. Cementitious systems involves either only cement or cement concrete. Cements are classified as ordinary Portland cement, blended cements or composite cements, and special cements. Special cements such as sulfate resistant cement, etc. Composite cements like low heat cement and so on. Concretes do contain cement, with ordinary Portland cement alone as the cementitious material, with composite cements as their cementitious materials, or more commonly, particularly in RMC plants nowadays, with Portland cement and site mixed supplementary cementitious materials. To understand the role of the SCMs in concrete, first let's understand the chemical and physical properties of cement. As we all know, the major component of cement is phase through calcium oxide, that is around 64%. Fineness of the cement is around 290 to 310 meters square per kg, particularly ordinary Portland cement of 43 grade sold in the country. Average particle size of the cement is between 20 to 30 micron meter, that is this is D50. The 50% particles in a given mass of cement are lesser than that of this size. This slide shows the properties of cements world over. Belite cement is another name of low heat cement. Type 1 cement has been the highest type of cement sold in the US, and SEM 52.5 is analogous to OPC 53 grade cement sold in India. SEM 52.5 is a brand of cement in particularly a type of cement in Europe. So this table shows that all these cements, particularly OPC 53 grade, ASTM type 1, SEM 1, etc., has C3S greater than 50% or so. As we all know that in ordinary Portland cement, the C3S plus C2S content should be in the range of 70 to 75% for it to be durable. Hence, only in the belite cement, C2S is more than 50 to 50%, whereas in all the other 53 grade cements or analogous to 53 grade cements world over, the C2S content is of the order of 20% or so, or even lower than 20%. A major weakness of cements, particularly type 1 grade or OPC 53 grade, etc., is that they are manufactured for strength, leading to high strength gain in early age. So this results in high heat of hydration and its evolution in the early ages. This slide shows the heat of hydration figures of OPC, moderate heat cement or low heat cement. As can be seen, that in the case of low heat cement, the heat obtained is around 60% of the OPC, and as also can be seen that the heat of hydration of C3S is about 2 times that of C2S. As can be seen that with the addition of fly ash, the heat of hydration can be reduced drastically. These two figures illustrate this. Increase in peak temperatures in its much earlier occurrence can give rise to undesirable thermal gradients, and these can create micro cracks in the concrete. These micro cracks can develop further when loading comes over the structure and turn into cracks, wide cracks. These get interconnected and form paths of ingress of moisture or ions in the concrete. With addition of fly ash or GGBFS, not only the total heat of hydration can be reduced, but also the kinetics of reaction, that is the heat of hydration evolution rate, can be decreased, and heat may be evolved over a wider length of time. This results in lesser microcracking in such concretes containing these materials. So now we discuss supplementary cementitious materials. Mainly 4 materials shall be discussed. As can be seen here, the GGBFS is of about white color or off-white color. Silica fume is dark grey color. Fly ash is generally light brown color, mainly in class F fly ash. Let's first discuss about ground granulated blast furnace slag in powder form. Furnace slag powder is a byproduct obtained in the manufacture of steel or the iron industry. This is generally contains a property which reduces heat in the exothermic reaction of Portland cement during cement hydration. The properties of slag are mainly its fineness, and the fineness of grinding affects its reaction or mechanism of reaction in concrete. Indian slag is generally of the fineness greater than cement, and its fineness generally varies between 350 to 500. Because of its high fineness and quality control, we have been exporting slag powder since last 2 decades to other countries. The price of such powder even in the country is at least equal to that of the price of the cement. The Micro-Silica is a high-end product which has been used since last 3-4 decades all over the world. Micro-Silica, also known as condensed silica fume, particularly when it is used in liquid form. The term Micro-Silica is used when it is used in powder form. This is a co-product of ferrosilicon and silicon alloy industry. This is mainly used for early strength gain and for increase in abrasion erosion resistance and hydraulic basin construction, increasing cohesiveness of the concrete mix, particularly in presence of high contents of superplasticizers, etc. The minimum silica content as specified in ASTM and Indian standard about specifications for micro-silica for use in cement concrete is 85% minimum. Similarly, LOI is maximum content of unburnt carbon, that is loss on ignition is specified. This is generally less than 2%, though the specifications allow up to 5 or 6%. This picture shows the grain size of the micro-silica. As can be seen, it is an ultra-fine material. The scale on the bottom of the right hand side shows 1 micron length. When combined with the spherical particles seen in the photograph or the micrograph, it can be very well visualized that most of the particles are less than 0.1 micron size. As we need to use high quantities of cement concrete, we may need to transport it with the dumpers and place it like as shown in this figure. In such a condition, when it is this concrete is transported and handled with mechanical means, a cohesive concrete as shown in this figure is very useful. The ultrafine material, that is silica fume or the micro-silica, helps in making the concrete as cohesive as shown in this picture. As we move to the construction of high-rise buildings, multi-story apartments, city malls, metros, etc., we need to use pumpable concrete. For pumpability, concrete must be cohesive. So micro-silica helps in making pumpable concrete. This picture shows a shotcrete, that is, a concrete is sprayed with a shotgun over a surface. This type of applications are very common in tunnel linings and the areas where landsliding is to be resisted. In large areas, particularly say Terry Dam construction or powerhouse construction inside the mountains, etc. So this type of concrete, when sprayed over the surface, tends to get down from that surface unless it has sticky properties. Micro-silica helps in rather makes it sticky so that the rebound of concrete from the surfaces gets low, so the usable concrete increases. If rebound is more, wastage is more. As we all know that bleeding is a property of concrete in fresh state. It's a defect that the cement slurry moves up to the surface of the concrete. If micro-silica or such ultrafine powder material is present in the concrete, it resists the movement of the slurry over the surface, that is the segregation. So the right side picture shows the no bleed water in micro-silica concrete. The Flyash is the foremost or rather most popular material in India. Most popular supplementary cementitious material used in cements or in cement concretes in India. So let's discuss about it. Flyash can act as pozzolanic material if it conforms to the specifications as laid down by Indian standards or the international standards like ASTM, etc., or European code, etc. As can be seen in the right hand side photograph, the particles of Flyash are mostly spherical. The average particle size ranges between 20 to 30 micron. That is, its average particle size is of the order of that of cement. So Flyash is mainly classified into two types across the world. One is siliceous Flyash, also known as ASTM class F Flyash. Another is calcareous Flyash, or known as ASTM class C Flyash. 90% of the Flyash produced in our country are siliceous Flyash. Mainly, presence of amorphous silica particles in the Flyash reacts with the calcium hydroxide produced during the hydration of cement and forms CSH gel-like material, which gives strength to the concrete. And next slide further illustrates it. This slide illustrates the reaction of Flyash with calcium hydroxide in the concrete. As can be seen that the concrete without Flyash, that is zero Flyash, the calcium hydroxide content increases with the age of concrete and reaches to 21 to 22% at the age of 1 to 2 years. Whereas in the concretes containing Flyash of about 20%, the percentage of calcium hydroxide reduces after 90 days or so, and it reaches to 16 or 15% at the end of 1 to 2 years. As can be seen that if the Flyash percentages ranges between 10 to 20%, the calcium hydroxide content with or without Flyash does not vary, particularly up to the age of 7 days or so. It also leads to a point that the reaction of fly ash mainly starts after 7 days or so. Simply adding any fly ash in concrete is not going to help. It should conform to minimum standards as laid down in the IS code to be used as pozzolanic material, and the fly ash to be used in cement concrete is to be obtained from electrostatic precipitators of coal-based thermal power stations. Fineness of fly ash should be at least same or finer than cement. The residue on 45 micron C is a major criteria for quality of fly ash. For low calcium fly ashes, reactivity directly proportional to amount of particles less than 10 micron C and inversely proportional to amount of particles greater than 45 micron C. As can be seen in this slide, if the percentage of material lesser than 10 micron size is greater, the strength obtained of concrete, particularly at early age, is high. Say, if the percentage finer than 10 micron size is 49%, the early age strength is 37.7 MPa. Whereas when it reduces to 29%, the early age strength reduces by 40% to 28.3. Even 90-day strength is higher in the case of concrete with higher percentage of material lesser than 10 micron C. Contrary is the amount of which is shown in the third column for 45 micron C. Shows the compressive strength variation with the amount retained on 45 micron C percentage, and this particularly is showing the fact that if the 45 micron C percentage decreases, the compressive strength increases. The pozzolanic activity index as defined in IS 1727 is higher if the amount retained on 45 micron percentage is lower. This is shown in this figure. Our issue is mainly that the fly ash as recommended in the last 2-3 slides is obtained in very less quantities from the thermal power stations. So the research was targeted to use all in fly ash, that is a mix of fly ash obtained from all the fields of the ESPs in thermal power station. Luckily, the results of such investigations are in favor of using all in fly ash, that is a mixed fly ash obtained from all ESPs, because it gives you a spectrum of particle sizes. So some particles help in densification of the matrix and so on. This slide shows that the water demand of the concrete can also be reduced if proper quality of fly ash is used. That is, fly ash particles greater than 45 micron C, if increases, the water demand increases. If the fly ash particles greater than 45 micron reduces, even the water demand can be reduced from the datum, that is 186 liter water required for 20 mm nominal size concrete, as we have learned in IS 10262 concrete mixed guidelines. This can be reduced. The fine particle fractions of cement and fly ash create a denser matrix during curing, and coarser particles and unhydrated cement particles, they remain as such and they act as micro aggregates in the concrete. This is particularly true in the high volume fly ash concrete. Let's discuss the basic properties of fly ash and its specifications as provided in IS 3812. We should ensure that any material which is called pozzolanic must have Al2O3 plus SiO2 plus Fe2O3 combined percentage not less than 70%. This is well accepted all over the world. So another point is physical properties, which we have been discussing, that how many particles are reactive. If we have reactive silica minimum as 20%, then only the fly ash can act as a pozzolanic material. Otherwise, it acts as only as an admixture in concrete. The roles of pozzolanic material is that any pozzolanic material reacts with calcium hydroxide to form CSH gel-like structure at a normal temperature or at ambient temperature. Whereas if it is used as admixture alone, then the reaction with calcium hydroxide doesn't take place. The fly ash particles remain as it is, like microaggregates in concrete, or even the finer particles which are not amorphous in nature, but particle size lesser than 10 micron may be there. They only densify the matrix. They do not react with calcium hydroxide. Durability of concrete can be enhanced by use of fly ash, as is shown in this figure. Permeability and chloride diffusion are the main parameters for durability. With proper fly ash and with proper amount of fly ash, the permeability can be reduced to its half, and chloride diffusion can also be reduced to about half. The above property of reduced chloride diffusion has been used or has been the main factor in deciding to opt for fly ash based concrete in the construction of famous Mumbai Worli ceiling project, Bandra Worli ceiling project, crown in India, in glory of India. So this construction took place around 2003, 2004, 2005, and it is serving the nation very well. So last 15 years we have seen that no deterioration of concrete structure has taken place, and it's a landmark structure of the country. The mega structure made with fly ash concrete in the last decade has been the Ghatgopar dam constructed with roller compacted concrete. A major indigenous supplementary cementitious material in the country is Metakaolin. This has got popularized, and IS code has come around 8-10 years ago for this in India. Raw material for this is kaolin, particularly available in Rajasthan. So metakaolin is a white pozzolanic material made by heating kaolin clay to a temperatures of around 750-800 degrees centigrade and finely grinding this material. Rapidly with the calcium hydroxide in the cement paste, converting into the strength bearing compounds. Metakaolin products conform to ASTM standards, and of course the metakaolin should also conform to the Indian standard code. Particle size is significantly smaller than the cement particles, and it is of the order of 1.5 micron meters with a specific gravity of 2.6 to 2.55 or so. Typical properties of metakaolin as produced by a firm 20 Micron Limited in Vadodara is about as follows in this slide. That is that the average surface area is of the order of 15 meters square per gram, that is around 5 times finer than that of the cement. And the SiO2 plus Al2O3 plus Fe2O3 content is around 96 to 97%. Calcium oxide is very minimal, and LOI is less than 1%.